All right. Originally, this talk was 10 ways to stop an Erlang virtual machine, but stuff happened, and now there are more. That's it. Everybody has one of these over here. For people online, capture the screen. The idea is that we were going to play a game. It's an anti-bingo. The idea is not to have a bingo, so don't scream when everything is scratched. Quite the contrary, that's when you lose the game. And so at the end of my talk, if you have a way to terminate an Erlang virtual machine that I didn't mention, you win the chance to come here and show the people that way, right? But now everybody will be writing stuff. So not to make an awkward silence now, I will speak about some stuff that you don't care, so it's in the video, and then we start playing. All right. Oh, why did it go here? Very good. So this whole thing started when, in 2016, I was suffering from insomnia. I still have insomnia, but I don't suffer anymore because I made a decision. The sleepless hours were invested in writing articles for my blog, this blog. I wrote more than 50 of them and eventually got other contributors, not necessarily suffering from insomnia, but suffering from being my friends, to contribute to the blog. And so this thing grew. If you ever wrote a blog, recorded a video, presented anything, you will know the story. You want to reach the largest audience possible, so you keep an eye on the stats. These are from Medium. I know Medium sucks these days, but it was a very nice and well-maintained site where it was easy to publish things at the time. And I kept watching the stats. These are from last month. I stopped writing like a couple of years ago, but I still have people reading the articles that I wrote in the past. The interesting part here is that this is, from the whole lifetime of the blog, the top 4 articles, right? The last one, Erlang Behaviors, took me more than a single night. It was a very research-like article. It actually has 2 parts. It's a very complex thing that addresses a topic that it's not addressed anywhere else. So I understand it's in the top 4. It's reasonable. The third one is a slightly controversial articles. Controversial articles are usually read a lot, or actually visited a lot. And it's also about Fred's book. So it's because of him, not because of me. And the second one was written by Carlos. And if you didn't read that article, read it. It's a great one. And the first one night I saw this meme, and I was like, yeah, I had to write something like that for the Erlang virtual machine. It will be amazing. Took me literally half an hour, and never, starting that day, there was never an article more popular than that one on my blog. Continually, every single week, I get 10, 20, sometimes 15 views on that article. And literally, I am that guy. Like, I don't understand. But people seem to be unable to leave the Erlang virtual machine for whatever reason. And it's not because of the lack of ways. We have way too many, you will see. But for whatever reason, it's a mystery. It's a mystery that I won't solve today. On the other hand, writing articles for the blog also helped me. What happened there? There you go. So writing articles for the blog also helped me do stuff like I'm doing right now, giving talks about the things that I wrote in the blog. Usually about the educational ones. But since I had never given a talk about this article, and it's the most popular one, why not? I am here exactly for that. If you want to see all the other talks, they are in my channel. You can scan the QR code. They are in my YouTube channel. I never learned how to put nice URLs for YouTube channels, and the one for this one is like super large, so QR code, that's it. If it doesn't work, just El Brujo Halcón in YouTube, you will find me. And now everybody has written their entries on the anti-bingo, so we will start killing Erlang machines. I will go through 3 slides now, particularly present in the slideshow, just so if I share the slideshow with anybody, they will see it. But don't worry, they don't have to pay a lot of attention. I will show them on a console. But I grouped the ways of terminating the virtual machine in 3 styles. The first one is the good one, then there is the bad one, and finally, of course, the ugly one. And if I can put my mouse over there, there you go. So the first one, the obvious one, how do you exit a virtual machine? Q, and done. So that one, if you put that one on your list, it was pretty obvious. All right. But you know what Q is? Do you know how that function works in the shell? It's because the function is in the user shell module. And it's actually calling this function, CQ. No arguments. So if you thought you were smart by using CQ, I got you. Then you have the actual function that's called from CQ. CQ is just a short way of calling the actual function that stops the virtual machine, which is amazingly named function. Init, init stop. If you say, hey, initializer, do the thing around it, stop it, and so it stops. Good. But there is another way, because init stop, what it does is it properly turns off everything in the node, all the applications, and then it calls Erlang halt. But we will see it later. And it returns something, because the Erlang virtual machine is a process in the operating system, so it returns a status. If you wanna specify that status, you also are allowed to do so with a parameter, like this. Init stop. I wanna close the virtual machine successfully, so 0. And if my memory of bash works, there you go, 0, right? It ended up successfully. But there is another catch here. Init stop, as I told you, turns off every process that you have, every application, everything, and it may take a long time. So there is a parameter that you can specify when you start your Erlang virtual machine, which is how much time do you allow your virtual machine to take to stop. For instance, 1 millisecond. And so if you start it like that, you can do init stop 0, like I did before, and I immediately go out with a message, right? Init shutdown time, it's interleaved because of concurrency. But if you check, not in this console, of course. If you check, it's still 0. It's fine, right? But quicker and dirtier, I would say. So now I can show you. I have prepared myself for this. I set up myself for this. I can show you a different thing. So I can put 1, 2, 3. Take some time. We do the echo thing, and 1, 2, 3. That's the status. At this point, when I did this the first time, I was expecting to find a crash dump, because the process ended up unsuccessfully. But there is no crash dump. Or it's actually something like this. And yeah, autocomplete already doesn't complete it. There is no crash dump, right? there are other ways of terminating the virtual machine which do generate a crash dump. So now, the one that I wanted to show you in the first place. After cleaning up the virtual machine and all the applications and everything else, there is an actual function that you can call to quit the virtual machine directly. And you can skip all the init stop part and just call that function. It's actually on user shell too, so you can do halt and boop, out of the virtual machine. If you do echo like that, it's successful, just like init stop. It's like init stop with shutdown timer 0. Of course, that function comes from a module. The module, in this case, is not init, it is Erlang. So you can also do Erlang halt, and once again, 0. OK. And of course, you can terminate with whatever status you want. For instance, Erlang halt 0, which I won't show you. It is 0. It's a successful one. But you can also use other statuses that we will see in the next section, the bad section. But then maybe the terminal is doing something like all the time, or you block the terminal with something like this. Let's see, X. OK. And oh, how do I write Q, halt, or whatever thing here? I'm stuck. So you can do Control-G, and you enter user switch command, and you can do all these amazing things. For instance, you can quit. There you go. You are outside of the thing. And funny enough, this is also successful finish. Then you can do what happened? OK, I have to reconnect. But then you can do something like that, but remotely. Where am I? Am I here? GQ. OK. So we have that one is a node. Node A is on my left side, on your right side. And I can start a remote shell against that one. Let's see if with the Wi-Fi and everything it works or not. It may take a while. But the idea is that if you use dash rem sh, you are actually inside the other node. So if you do Q, which one of those two nodes will terminate? The remote one, because you are running commands on the other one. You see? And this one, it will tell you, hey, the other node died, but the node here is still alive. It has no shell, but you can still do Control-G and whatever, the same things as before, for instance, Q. So that way, you can remotely terminate the other node, which in general is a mistake. You are usually trying to close the remote one, not the server that you are diagnosing. But if you want to terminate it, it's up to you. And the next thing you can do, no, not this one. There you go. The next thing you can do is, once again, block yourself. And instead of Control-G, you can press Control-C. And Control-C already prints the help, which is nice. And as you can see, there are two ways here. The first one is to press the lowercase a, abort. And that, of course, terminates with success. And the other one, I think I will show you later. I'm not sure of the order of these terminals, but let's see. Oh, of course, I forgot this one. You can again, OK. Let's imagine you are blocked there, so you press Control-C, and you don't understand what's going on, and so you're very like, no, I want to go away of this computer. Cool. Control-C again, that's fine. And once again, even when you were very, very brutal and terminating the computer, it ended up successfully. It's like that. OK, let's go. Those, I didn't count, but 10, 12 ways are the good ones. All of them end up successfully if you choose the right number, right? They end up cool. No, not generating crash dumps, nothing. There are other ways where you can terminate the machine by being very specific and telling the system that something really bad happened. The first one is the one that I incorrectly tried to show you before, which is Erlanger with whatever status you want. And in this case, once again, the status is the status, and that's it. But there is more. You can also use an atom there. This one, I learned about it. This was my latest finding. I learned about this one like a month ago or something. But you can do this. And it's aborted. Now, who knows what's the status code of that thing? Oh, yeah, I don't feel that bad. It's actually 137, I think. No, 34, close enough. It's 134. And does it generate, I think it does. Does it generate a crash dump? No. So just 134 out. So abort is a code for 134. It's the same. And then you can also use your own slogan. And I will show you what your slogan is right now. You can do hold, and you put a string in it. That will abort the thing, print out your slogan over there, and generate a crash dump, right? And I won't show you the whole crash dump because it's crazy. But if you see, the status is 1, and the crash dump looks something like this. I think it was the 4th line, or maybe the 5th. And you see here your slogan, my fancy slogan, you see? So the rest of the file is the usual crash dump with all the processes, the memory, the ports, and everything else. But it specifically stated that it terminated because of the reason you want. Remember, you can do this on the terminal, but you can also do this on your code. This is dumb on a terminal, but if your system must actually terminate for a particular reason, you have the chance to specify that reason in particular. And so the server, the crash dump informs whoever is reviewing it about the actual problem. I didn't tell you before, but my current day-to-day job in my current company is exactly that, reviewing crash dumps and logs and stuff. So learning that this is possible was like a big deal. I gathered the whole team and I was like, people, if you're about to crash the server, please tell me why, right? And then you can do the other thing that we saw before, Control-C, and then uppercase A, which is an abort with dump. So it aborts with dump. And this is the same thing as before, but the slogan is crash dump requested by user. As you can see here, it's 134, but the trick is, there you go. Crash dump requested by user. Do you see the issue there? It's like in a -n. They already merged the pull request that I sent when I was preparing this talk to add the -n, so it will look like the other crash dumps. And the rest of the crash dump is the same as before. So OTP 28, I guess, will have the new line before system version. I was very, very much tempted to add an emoji or something there, but I restrained just in case the OTP team doesn't feel that happy about it. And then we have other ways to stop a virtual machine in systems where kill exists, which are the usual ones. So if you have a node like this one, node B over there running, and you are on the shell, you can do something like this. And you have a process 80-121, so you can kill it with the usual signals, sigterm 8-121. Let's not kill anything that doesn't need to be killed. And there you go, it's terminated. And once again, the status is 0 because sigterm is terminated successfully. And there is no, I'm removing the old one with the abort before, right? There is no new Erlang crash dump. It's a successful termination. So if you want to kill your Erlang virtual machine without using Erlang, you can use kill sigterm. But you can also use, we have to do the same to get the PID. This one is node C. So we can kill it violently with this. Whoops, with this. And it's terminated more violently. And if I recall correctly, this is a 1. No, this is also 0. Oh, I remember what's the difference. With sigterm, it goes through init stop. With sig quit, it goes straight to Erlang halt. Just terminates, period. And then you get sig kill, which is the brutal one. Once again. Let's do it. So 80, 20, 15. And this one, you see here, killed, blah, blah. And I bet it has a different status, but I don't remember. Yeah, 137. Oh, this one was 137. Found it. Got it. Good. So I think no crash dump here, but just in case. No. OK, cool. So this is another way of killing the virtual machine. And I found out we have multiple other signals. I won't show you. It doesn't count. If you have a signal that I didn't list, it's all counted here because there are like 10 of them. One of them is SIG-USR1. And so once again, node E. And this one is particular because, if I remember correctly, it's the first one that was introduced back in OTP 20 whatever. That was the first one that understood exit signals from kill. Yeah, and this one actually writes a crash dump. You see? It's status 1, and the slogan is received SIG-USR1. The other signals do different things, but all of them terminate the machine, and the slogan is usually received whatever the signal is. And then we have the ugly ways, my favorite ones. And the first one, there is a bunch of them. I will show you now one after the other. They are all ways to start the virtual machine that is automatically terminated. This one is like you say -s means Erlang, start this thing, and you pass in something that's ludicrous, like a bomb. And so, hey, Erlang, start this bomb, and die. Very good. Because bomb is, of course, undefined. So I will show you this only once. It's one now and forever. Like all of the following ones are ones. And The slogan in this case is what you see there, I think. Yeah, init terminating in do boot, undef, blah, 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 blah. OK. But OK. Start, not good. So Erlang start, and then run this function. Init stop. I told you before, init stop terminates the virtual machine. So there you go. It started, it terminated, that's it. I will take this opportunity to remove this one. And then you can evaluate something that terminates the virtual machine as well. Another bomb, another crash, and there is again a slogan like the one I showed you before. It's just running Erlang code, which terminates the virtual machine. And then you can tell Erlang what boot script to use, which is also a bomb. So it also terminates because it doesn't know where that boot file is. You know the slogan, I won't show you. You can check it if you want. And then you can tell it to start with a bombing configuration. Once again, where is that bomb? But in this case, emoji support is missing. Don't ask me, Erlang thing. But same thing, without the emoji support, probably because it auto adds the .config at the end and it messes up like what, that number 128, 160, whatever. OK. Anyway, it terminated, which is the important part. And you can also name your virtual machine with an improper name. And boom, you got a lot of descriptions there with the supervision report and whatnot. But the application cannot start, and so it's terminated. I think, I don't remember the slogan for this one. I think it's kernel pid terminated or something like that. Yeah, kernel pid terminated, application controller, blah, 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 blah. Which gives you a clue on something that we will see later. Application controller seems to be an important process. So we can terminate it. This is something like, where is application controller? Yeah, you seem very important. So die. There you go. Yeah, kernel pid terminated, killed. OK. But application controller is a Gen server. So we can, it's a Gen server with a name. So we can stop it, right? Goodbye. And there you go, once again. Kernel pid terminated, but look, normal, not killed. This one is normal. It's a bad normal thing. And then we can also exhaust the only limit that I found. But if you exhaust any of the limits, but this one is easy to exhaust, the atom limit. The atom limit is whatever number. Atoms are not garbage collected. So if you do let's do list comprehension, which is nicer. And you do list to atom integer to list. List secu 1 to Erlang system info atom limit. And of course, atom limit is an atom, so I have at least one more, which is the important part here. And so very, very quickly, boom, no more index entries on the atom tab. Yep. And that's the slogan. I won't show you, but that's the slogan, the same message with the max and everything. And you can do the same. What was I trying to do here? Oh, you can also remember how I told you that when you were on remote shell, you kill the other node by running code on your own one? You don't need to be in a remote shell. As long as two nodes can see each other, you can do RPC, call this other node that I know it exists and it's close by. The function will be Erlang. And let's do a clean halt with no arguments. And whenever the network succeeds, this node finds the other and blah, 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 it will terminate the one on your right side. But keep leaving. But this one will still live. The most amazing part is that the return of the bad RPC is not it didn't work or it failed or no, it's like the node is not there. I don't know what you're talking about. So let's terminate this one too. And of course, you can also, since application controller we already learned is a Gen server, we can do Gen server, stop, but I don't want to die. I want to kill the other node. So sneaky thing, if you didn't know, you can call Gen servers in other nodes by using, if they are registered locally, by specifying the node as a second part of the tuple. So, whoops. So I can very, very nastily kill the other node once they find each other. And boom. And once again, I don't know what you're talking about. There is no connection. Nothing happened. Yeah, just a second. I think there are two missing. I don't remember actually, but oh yeah, there is only one missing, and this one is fantastic. Brian Paxton saw that I was going to give this talk here, and he specifically found me, and we had a video call, and he showed me this way that I didn't know, and it's very funny because it involves observer. And now, if live coding ever worked, this is a time for all the prayers. OK, so where is this thing? Here. Oh, come on. Oh, I know what I need. I know what I need. I need to be in this thing here, and so I can pick up the window and move it there. There you go. It's very small, I guess, but you can on Observer you can find the processes, right? You can sort by PID if you want, and these three look very important for the virtual machine, so you can go and kill them. And there you go. System process 020 is terminated, killed. It's the same thing as the application controller. Down, you kill the virtual machine too. And that's it for me. So now, if you have other ways of killing the virtual machine and we don't have time for questions, you can send me those things in the Huba app or put it in the chat or whatever, show them, tweet them. If you won, congratulations. It took me, this article was written 10 years ago? No. 8 years ago, and I collected all of them during these 8 years. So you find something that I couldn't find in 8 years, you are amazing. Thank you very much.